Hello, I'm Philip Stoten. I'm here on the Scoop Studio at Productronica 2017, and I've got two guests with me to talk about the concept of digital twins. We have Oren from Mentor and Jason from Aegis. Gentlemen, first of all, let's just understand what we mean by the term and what it means to you as a company.
Okay, so for me, Mentor, of course, now after the acquisition of Siemens, we are, I think, kind of going and integrating into the Siemens story and how they view the digital twin. And we really talk about three here. We talk about a digital twin of the product, a digital twin of the manufacturing process, and a digital twin of the production. And what we mean here is really we're creating a full virtualization, simulation of the product we're going to build, how we're going to build it, and the actual execution offline. And this way we can do, of course, a lot of simulation, a lot of analysis, a lot of offline testing, if you want, on this before we actually go and build the real thing.
Okay. And Jason, we've been offline programming machines for ages, and we just never called it a digital twin. And we've been doing it the whole time. And what does it look like from an Aegis standpoint?
Well, the digital twin, and I think Oren touched on something, there are a lot of different definitions, honestly, as I move around the industry and read some articles as to what the twin versus the shadow is, and there's new words every day. We at least look at the digital twin as the as-built, almost like the device history record of the as-built configuration of everything from the software versions to the content to what operator touched it when it was in, I'm sorry, that's the shadow. But then there's the shadow, which is the experience it had as a product from PLM, from design, all the way through production. So there's the shadow of its past that made it what it is, but then there is what it is. And yes, actually, we've been doing that for a very long time at the virtual level, and so because it's a fancier, more comprehensive way of looking at traceability. So in a way, yes, there's been elements of it. It's just I think it's very helpful now that there are terms that are better to grasp it, because before traceability was perhaps a machine line puts out what parts went on that unit. That's not really, we've always talked about total traceability. Digital twin and shadow are a better way of saying it than that.
Yeah, I like the idea that the shadow is maybe the past or where we are up until now, and the digital twin is now, and the digital twin is maybe what we can project forward. I've talked to a lot of EMS companies about this, and one of the examples that came up from the Hanover Fair was the McLaren example, where they run a digital twin of every car on a simulation of a circuit. They're able to project it forward and see what might happen. That ability to project forward is, I think, what excites some of the large contract manufacturers if they have digital twins of literally their whole factory footprint. Is that something customers are asking you for, Oren?
Yeah, for sure, and I have to agree with both of you gentlemen that we've been doing these kind of things for a long time, but we've never really called it this kind of digital twin. So the story is good. I think the shadow maybe a little bit confuses people, and that's why we do talk about digital twin of product, manufacturing process, and the actual production. So with manufacturing process, we are defining the actual shop floor, we're defining all of the machines, we're defining how this product is going to be routed, and we can do some simulation on it. So of course, we've been doing DFM analysis for years, and in essence, this is a simulation of how the manufacturing process is going to be, but we've never really called it a digital twin, we've never really called these terms. I think we're now slowly adapting and using this, to really give it a better framework and give it a better name. I think it also means more to management. Yeah, you can collect traceability data, you can collect this, but if I'm the manufacturing manager, I don't really understand. When I come to you with a digital twin story and I explain to you and you see the kind of McLaren example, I think it's much more vivid, it's much easier to get. And again, I think the idea is here, let's try to simulate as much as we can before we build one board, one PCB, in order to make sure that the product is correct, that the manufacturing process that we've defined is correct. And then finally, this digital twin of the production, that's really the execution data, that's the actual traceability data, which we can now take and also cross-analyze with what we thought would happen to try to see where we are compared with what we wanted to do. So as an example, we could run a DFM analysis, but then let's see whether from a quality perspective, we're actually finding defects where we knew there was a DFM issue and where we thought we were good, are we really good? So these types of correlations, people don't do today. They run very sophisticated analysis, but then they manufacture, they collect the data. They never go back and try to see, did we expect issues where we found them, did we not? And is our analysis and our simulation really good, or do we have to fine-tune our constraints files and our definition to get a better modeling and really prevent these errors? So I think that's what we're going to see, more of this closed-loop manufacturing and taking back the data, comparing with the digital twin and of the product, and making sure that we really improve. So that's probably things we're going to start seeing more and more.
Yeah, and people are going to want to see new value from that, and that's really important. So when you look at it from your point of view, Jason, is it something new that you're going to be bringing to the product as a result of digital twin, or is it the way you use the data you already have?
Actually, architecturally, we've had this for a very long time. Because we have a singular system, every single data source in the entire enterprise is in there already, and so forth. But we look at it a little differently. Your original question, I believe, was, are the customers driving it? And I see, perhaps what Oren was saying was a bit like, how do you iterate back to the PLM to see whether happened was what you predicted? And so we see a different direction in the chronology of what the customer's interest is. It's, if you're McLaren, BMW, there's articles out there about this. When you ship a vehicle, we have this in the defense customers a lot, they ship a device. Nowadays, there might be 30, 40 different subsystems in there with firmware revs, different versions, different cards. They ship it out. It goes through a field service life cycle. They can't do the field service if they don't know every single version of everything in that unit, because as you know, sometimes the way they design these systems, they upgrade one firmware and it's wrong, the whole system fails. It's a serious problem, especially in vehicles. So knowing everything as it's shipped and then being able to know it from the field service systems later, so you can keep that twin up to date outside the factory, is what we actually are, that we see that as a big thing that we're being asked about.
Yeah, so digital twin of the product, digital twin of the process, digital twin of the production line, and maybe if you're a Jabil or a Flex, digital twin of your entire manufacturing environment. That's where it gets really interesting. And I think we're going to see more of this, more AR, more AI, whether it's just us relabeling things we've been doing or actually doing new iterative improvements.
Yeah,
they're coming.
I do think one additional thing that we're getting asked is, this whole high mix and low volume, small lot sizes, we're really seeing it come to this lot size one. So the ability to really make one-off. And as you were saying, we see with these cars, they're unique. We all want to, configure our own car. So you buy a new Ford Focus, you can choose every system in there, a sunroof, you can choose the engine, you can choose the infotainment. At the end of the day, probably the car that they're building for you is unique. And for that, in order to be able to really manufacture a PCB in a lot size one and get your process right very fast, you need some of this digitalization story, because you really need to do the offline simulation. When you had the batch of 10,000 boards, you could take a couple of hundred of boards, get your process intact, fix it on. It was maybe 0.5% of the actual, but when your lot size is 5, then you don't have the luxury of getting it right after 2 boards. You really need it right the first time. And I think that's what is pushing this digitalization. This is really the solution that we can bring to the customers to do something with this high mix or extreme high mix, low volume, and up to this lot size one.
And lastly, for you, Jason, it's not just the SMT industry. You're operating in a lot of discrete markets, a lot of other industries. Are they talking about it in the same way?
Oh, more so, actually. They want to do mass customization now, which our system is architected to do fundamentally. We might look at it slightly different. To us, it's almost like simulation is the antithesis of mass customization, because you don't have the time to do the simulation of an infinite number of permutations. You have to have the system fundamentally able to adapt to that which comes down from ERP, which you literally cannot predict, because in the old days, if you remember, we just used to have the option packages maybe be 3 on a car. Now, as you said, Oren, it's almost, the permutations are getting so great that the manufacturing control system has to fundamentally be able to adapt to that without having been pre-configured to do it. And that's what we see.
Yeah, and it's knowing that it's your car going all the way through, and it's fully traceable from your online order to the point it reaches you and beyond.
Mass customization with single piece flow does not mean they don't want all the digital twin and the trace. Now everybody wants everything,
which
is great.
And they still want the economies of scale manufacturing. Gentlemen, thanks very much for your time, and enjoy the rest of the show. Thank you.
Thank you.